So let's do this entire worksheet. I have my trig IDs, I have my unit circle, I have my calculator, and just as importantly, I have my Twizzlers. So share screen. Right. Number one. 1a. So we have tangent theta plus 1 equals 0. Subtract the 1. So now we have tangent of theta equals -1. Now we recall that tangent could be looked at as y over x. So where on the unit circle, if you take a look at your unit circle, where can you go so that the y coordinate divided by the x coordinate equals -1? Well, on your unit circle, that would happen here and that would happen there at 135 and 315, because at those locations, the x and y coordinates are the same number, but one of them is positive and one of them is negative. And it doesn't matter which one's positive, which one's negative, as long as it is one of each. And that's why the answers are 315 and 135 for 1a. Now for 1b, we have cosecant theta equals square root 2. Now recall a trick that we've discussed before. And that is, you can turn cosecant into sine like that, but you'd have to reciprocate the other side. That's a trick that you can do. Turn secant into sine, but the other side gets flipped. Now from here, maybe we can rationalize the denominator. I can multiply top and bottom by square root 2. The top would be square root 2, and the bottom would be a regular 2. And this is a number that we recognize big time. So sine is the y coordinate. Theta is an angle. Where is theta? Theta is an angle. Give me an angle where the y coordinate is positive square root 2 over 2. On the unit circle, that would happen here, and that would happen there, which is why the answers would be 45 and 135. So 45 and 135. For 1b. For 1c, we have 2 cosine squared theta minus cosine theta equals 0. So here we have a common factor of cosine. I would factor out a cosine theta to the front, leaving us inside with 2 cosine theta minus 1. Just pause real quick. I know that this is correct because if I use the distributive property right now to what I have, I would get the original statement. See that? That's how I know that my first step was correct, because it leads me back to the original. So let's continue. So now we have it factorized, and this times this equals 0. So that implies that maybe the first component equals 0, or maybe the other factor equals 0. So we set them both equal to 0 and solve. Here, cosine is an x-coordinate. An x-coordinate is supposed to be 0. Give me an angle theta where the x-coordinate would be 0. Well, that happens here, and that happens there. So far in the bag, we have 90 degrees and 270 degrees. Let's see what this other equation gives us. Why don't you add the 1 and then divide by 2 afterwards? That would say cosine theta equals positive 1 over 2. Where does that happen? Where do you have an x-coordinate that says positive 1/2? On your unit circle, that would happen here, and that would happen down there, which is at 60 and 300, which is why this equation had 4 answers, right? If you check the answer key, it should be those 4 answers. 1D. One direction. All right, so 1D, we have sine squared theta plus, what does it say, 5 sine theta minus 6. So here I would recommend that you make a u substitution. Let u equal sine of theta. And then rewrite this problem in terms of u. So it would say u squared plus 5u minus 6. And then go back to your high school days when you factorized trinomial expressions. This quadratic has the following factorization: u plus 6 times u minus 1. This is the correct factorization, because if I were to distribute or FOIL, I would get back the original statement. Okay, so we have this factorized, and now set each of these factors equal to 0 and solve. So the first one, u would be -6, and then u would be +1. So the value of u is two things. It's either -6 or +1. Take both of them and plug them in for u, because we're trying to find theta. So one of the setups would say sine of theta equals -6. And the other equation would say sine of theta equals u, which 1 was the other option. Looking at this one here, the y-coordinate is supposed to be 1. Where do we have a y-coordinate of 1? That happens only at 90 degrees. So for sure, 90 degrees is in the back. This other equation is an impossibility, because you want sine the y-coordinate to be -6. That's not possible on the unit circle, because it's limited to 1, right? You can extend from the center 1 unit in any direction, not more than 1, definitely not 6. So this equation gives us no answer. So the only answer we got was from the other equation, 90 degrees. Number 2. So they tell us for number 2, they give us secant of theta equals 2, and then we have 270 to 360. So we're in quadrant 4. Let's go to quadrant 4, right? That just means quadrant 4. Go to quadrant 4. Let's see. So we are operating right there. So this is 2a. And so we're down there. And secant is, if you look at SOHCAHTOA, secant is hypotenuse over adjacent, right? If you look at your cheat sheet, your green cheat sheet, secant, hypotenuse over adjacent. So the hypotenuse is 2, and the adjacent would be 1. And Pythagorean theorem would say square root of 3, but like negative, because you go down, 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 down. Theta is what drops us off at our location. That's us right there. Now, what do they want for part A? Let's see. They want the sine of 2 theta. So look at your double angle identities. Looking at your green cheat sheet, look at your double angle identities. We know that sine 2 theta equals 2 times sine times cosine. Keep the 2. What's sine? Looking at your picture, right? We have a diagram. Sine is opposite over hypotenuse. So that would be negative square root 3 over 2 times cosine, which would be adjacent over hypotenuse. And just type that into your calculators and you're done. I believe the result would be negative square root 3 over 2. Done for 2a. Now 2b, or not to be. Let's see. I think we have the same picture, right? For 2b. Got the same diagram. 2, 1, negative square root 3. Now here the goal for 2b, what was it? It says tangent of theta halves. All right. We have tangent theta over 2. That's a half angle. So looking at your green cheat sheet, look for your tangent half angle. And one of the options, excuse me, one of the options for tangent of theta over 2 would be 1 minus cosine over sine. Yeah, right? That's one of the options for tangent of theta halves. And so we have 1 minus, well, cosine, we just found from the previous problem. Cosine would be adjacent over hypotenuse. And the bottom would be sine, which is negative square root 3 over 2. And from here, you should just go calculator to get your answer. But if you want to do a little bit of work, we could multiply top and bottom by 2 and distribute. Because if we do that, let me go over here. And if you distribute 2 on the top, that would be 2 minus 1 over negative square root 3. And actually, we could have just subtracted 1 minus 1/2. But either way. 1 over negative square root 3. And if you rationalize, you get a final answer of negative square root 3 over 3. You could have left it like that or like this. It doesn't really matter. I'll accept either one. But do try to clean up something that looks like this. Just type it into your calculators. And don't give me like a weird decimal for a problem like this. We want the exact answer, which could be either one of these two. All right, let's keep going. So that was to be number 3. Number 3. Get this out of the way here. Let's see. Move this out. 3. So we have, so this is 3 A, B, C, D, basically. So it says sine of theta equals 3/5. And we're trying to find all kinds of stuff. I think we can just do all 4 of them in the same screen. Let me just call this 3, period. So part A. Cosine negative theta. Well, looking at your cheat sheets, go to even odd identities. Cosine negative theta is the same as cosine regular theta. Now, maybe what we can do is make a picture. They didn't say which quadrant to go to, so just draw a basic right triangle. Sine is opposite over hypotenuse. So my opposite is 3. My hypotenuse is 5. And per Pythagorean theorem, the missing leg would be 4. Now, as we work, part A. Cosine negative theta equals cosine of regular theta. That's on your cheat sheet. Look at your even odd identities. It's right there, right? It is right there. And so give them cosine and you're done. Cosine would be, there's theta. Cosine would be adjacent over hypotenuse. So we'd have 4/5. Part B. We have cotangent squared. So it says cotangent squared theta. Maybe we can write this like this. Write it as the quantity cotangent theta to the power of 2. Keep the power of 2. What's cotangent? Cotangent would be adjacent over opposite. So that would be adjacent over opposite. And that gives us 16 over 9. Done. Part C. Tangent of theta minus 10 pi. Recall that for tangent, for tangent, fact, tangent of theta plus or minus k pi is just going to be tangent theta. As long as k is an integer, it could be plus or minus, doesn't matter. And k could be even or odd, doesn't matter, just make sure it's an integer. And if it has a pi attached to it, then this basically goes away. And it just gives you the regular tangent of theta. And that's what I want to do for our problem here, right? Tangent of theta minus 10 pi is just equal to tangent of theta. That's based on your the periodic properties, which are on your notes somewhere. So tangent would be opposite over adjacent then. And then finally, part D, we have the secant of 6 pi minus theta. Well, here, if you add or subtract by an even pi, it cancels for sine, cosine, tangent, and for all of their reciprocals. So here, the 6 pi can basically go away. So we're just left with secant of negative theta. And that's the same as 1 over cosine negative theta. And then based on part A, right, based on part A, cosine of negative theta equaled 4/5. So this is 1 over 4/5, which cleans up to become 5 over 4. So that's all of number 3. Let's now look at number 4. Use a difference identity to evaluate cosine of negative 15. So number 4, cosine of negative 15. Well, that's the same as the cosine. That's the same as the cosine of 30 minus 45, because 30 minus 45 is negative 15. And 30 and 45 are angles that we're comfortable with. We see them all over the unit circle. So here, call this A, call this B. Pick up your green cheat sheet and look for cosine of difference identities. Cosine difference identities on your cheat sheet. So cosine A minus B becomes cosine A, cosine B, and then it says plus sine A, sine B. And then look at your unit circle to find each of these four individual pieces. See that? Yeah, based on the unit circle, cosine of 30 would be square root 3 over 2 multiplication. Cosine 45 is square root 2 over 2. Sine 30 would be 1/2 times square root 2 over 2. And just type that into your calculators or just look at it and jot down what the answer would be. This guy right here. Square root 6 plus square root 2 all over 4. Common denominator of 4. Turn the paper over. Yeah, now these are a little more interesting on the backside. You see, so number 5. Given that diagram, state the value of that. Let's see, so number 5, we're given, let's see, so we have theta, which drops us off in quadrant 2. We have -4, we have 5, and Pythagorean theorem, where's my calculator? Pythagorean theorem for the hypotenuse, what's 25 plus 16? 41, so this would be the square root of 41 for the hypotenuse. And then what's the goal for number 5? We want the sine of theta plus pi thirds. That's a sum identity. Sine of something plus something looks like a sum identity. So look at sum identities and look at sine. And that would go sine of A times cosine of B plus cosine of A times the sine of B. So like the previous problem, we have 4 parts to take care of. Let's see the first part. Sine of theta. Well, theta is the angle that drops us off, and we are standing right there. Sine would be opposite over hypotenuse. So this would be 5 over square root 41 times the cosine of pi thirds. You do not need the picture. You don't need the picture for this. You don't need the picture for that. You need the unit circle, right? Go to pi over 3 and tell me cosine, which is the x coordinate. So at pi over 3, go to pi over 3, which is at, where are you? 60 degrees. Cosine, the x coordinate is 1/2, which is why this is 1/2. Now over here, cosine theta, you do need the picture. The picture is dependent on theta. Cosine would be adjacent over hypotenuse times the sine of pi thirds. Go back to the unit circle. Sine of pi thirds would be square root 3 over 2. So this would be like 5 over 2 square root 41 minus 4 square root 3 over 2 square root 41. It's convenient that we have a common denominator. We do. So just merge the two fractions into one, and you can stop right there. So 5 minus 4 square root 3. You don't have to go any further than this point. Just leave it like that. Well, it's good enough to me. Number 5. Number 6, state the exact value of that. All right, let's shut this down. So we have cosine. We have cosine of tangent inverse. I'll just write it as tangent inverse of 2 plus cosecant inverse of 3. Here, this is the kind of problem where I would make 2 triangles. And maybe we can make some assignments. Why don't we let tangent inverse of 2 equal theta? And why don't we let cosecant inverse of 3 equal alpha? So here, why don't you take the tangent of both sides? If I take the tangent of both sides, it would say 2 equals tangent of theta. Put a 1 down there. Over here, take the cosecant of both sides. That would say 3 equals cosecant of alpha. Here is a little picture. Right? Let me draw a right triangle. This one is for theta. And over here, this right triangle is for alpha. Now, theta, right there, that's theta. So here's its picture. Tangent is opposite over adjacent. So the opposite is 2. The adjacent is 1. And Pythagorean theorem for the hypotenuse. On the other triangle, put a 1. Cosecant is hypotenuse over opposite, right? Cosecant, green cheat sheet. Hypotenuse over opposite. So the hypotenuse is 3. The opposite is 1. And Pythagorean says that. So I would make pictures. Now go back to the main problem, okay? The main problem right here. Cosine, parentheses, addition. What could replace tangent inverse of 2? Well, what does tangent inverse of 2 equal? It equals theta, because we said let tangent inverse 2 equal theta. So this becomes theta by substitution, because they're equal to each other. Similarly, what could replace cosecant inverse of 3? Alpha, right there. So look at what you got down here. We have cosine something plus something. That's one of those sum identities from the cheat sheet. That's a cosine sum identity, which becomes cosine of theta, cosine of alpha, and then it says minus sine of theta, sine of alpha. Again, those 4 pieces. Cosine theta. Go to the picture with theta. Cosine would be 1 over square root 5. And this one says cosine alpha. So go to the picture with alpha. And that would be square root 8 adjacent over hypotenuse. Here, sine theta would be 2 over square root 5 times. And here, this would be 1 over 3. And if you combine all this mess together, you should get square root 8 minus 2 all over 3 square root of 5. You could totally leave your answer like that. That looks beautiful. You don't have to clean it up if you don't want to, although you can. You have that option. Okay? For number 6. Yeah, that was number 6. Number 7. We're almost there. Number 7. So you're standing next to your car, and then you walk 30 feet from your car due east. So here is where we start. And we're going to walk that ways, and we're going to stop, and that's 30. And then it says, from there, you're going to walk 80 feet. But in which direction? We're going to go 80 feet in the direction 20 degrees south of east. Look, this is where I am right now. That dotted line represents east, like to the right. But I'm not going to go east. No, I'm going to go south of east. I'm going to aim below east by 20 degrees. So I'm facing this ways, but I'm not going to go that ways. I'm going to aim 20 degrees down, and boom, that's the direction that I'm going to walk. See that? That's the path that I take. Not east, 20 degrees below or south. And that would be 80. What else? And then you walk X feet to the west or west. So that's to the left. So now we're going to walk this ways. And I think we're going to stop right underneath where we started, because it says that after you go X, you have the ability to walk straight up to hit your original spot. So you know that they said X feet. So you know you have to stop here because it's right below where you started. And the goal is to solve for X. Can I convince you that X is nothing more than 30 plus Q? That's all it is, right? Because it's parallel. It's like a rectangle, like parallel streets. That's what X is. X is the goal. But X is the same as this 30 plus this Q that I just created, right? So solve for Q, add it to 30, and that represents X, and we're done, right? Because they're parallel, they're congruent. How do I solve for Q? Well, look at the picture, right? Look at this triangle here. Let's take a look at this triangle. That's all you got to look at, right? Let's look at that triangle. We know this is 80, and we know this is 20, and this is 90, and that's Q. I think we just have to go to the first week of the semester with sine, cosine, and tangent. I would argue that all we need is cosine. Look. Cosine of 20, not 2 theta. Cosine of 20, right? Cosine 20. Cosine is adjacent Q over hypotenuse, right? That's cosine. Cosine is adjacent over hypotenuse, Q over 80. Multiply both sides by 80 to cancel these out. And so Q equals 80 times the cosine of 20. Calculator says that that is about 75.18 miles, feet, whatever this is. That's Q. But in addition to 30, so if you add 30 to this, that gives you the answer that you saw on the key, 105.18. This is feet, it looks like. So that's how you can get that answer for number, this was number 7. This was number 7. Number 7. All right, 8, 9, 10, 11 are all like, what is it, areas or let's see. So this is number 8. All right, number 8 here. Boom, boom, boom. This is 120. This is 2x, and this is x, and this is 5. And the goal is W. That's the goal. Now, in a triangle, the 3 angles add up to 180. Look, what are the 3 angles? 120, x, and 2x. All together, if you add up all 3 angles, it's supposed to be 180 every time. So 120 plus x plus 2x is 180. Take away 120 from 180 and combine 2x plus 1x to get 3x. Right? 120 from 180 is 60. 1x plus 2x is 3x. Divide by 3, and we discover that x is 20. So we know that this is 20 degrees and this is 40 degrees. The goal is to find W. I think we can use law of sines. Couldn't we use law of sines to find W? Couldn't we say sine of 40 is to 5 as the sine of 120 is to W? Law of sines. Cross multiply. Okay, cross multiply here. And then divide, I get W alone, and you'll see that it's about 6.7-ish. So W is about 6.7-ish. Feet, whatever. Units. All right. See, good. That was 8. Let's look at 9. Let's see here, number 9. Solve for G. So we have like that, like that, like that. We have 6, 5, 4, and we have G. Law of cosines. You got 3 sides. You're probably going to use law of cosines if you're trying to find some angle. Law of cosines. So use law of cosines to find G. And your setup for that should look like this. It should go 4 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of G, because G is an angle. It's the cosine of the angle. So we have 16 equals, give me 25 plus 36. Was that 71? 25 plus 36. Wait. 25 plus 36. 61 minus 60 cosine of G. Subtract 61 from that to get what, 45? Negative 45? Negative 45. I don't trust my arithmetic. Negative 45 equals negative 60 cosine G. Divide by negative 60. Divide by negative 60. Bye-bye. This is going to be 3/4 equals cosine G. But you want G, the angle. So to get G, take the cosine inverse of both sides. So cosine inverse of the left, cosine inverse of the right. These would cancel. And on your devices, cosine inverse of 0.75 is about 41.4. So G is about 41.4 degrees for number 9. Number 10, find the area of that. All right. Number 10 looks like this. Boom, boom, boom. This is 10. This is 12. And this is 23. I'm totally going to use this formula. Area equals 1/2 side times the sine of the angle. Totally going to use that. But here's the thing. Look, I know that 10 and 12 go here. But 23, nope, that's not theta. No. In this formula, theta is the angle that's stuck between the 2 sides that are given. See that? So 23 is not our angle. We want theta. Well, let's find theta. Look, how about first you find x with law of sines like this. Look, let's go sine let's go sine of angle 23, and its matching side would be 12. And let's go sine of angle x, because that's going to be 10. Let's find x, and then we can find theta. Once you know theta, you can put it in there, and then we're done. So here, why don't you cross multiply? So we'd have 12 sine of x equals 10 sine 23. Divide both sides by 12. Bye-bye. Divide both sides by 12. So now we have sine of x equals 10 sine 23 over 12. And then get x alone by going sine inverse. Sine inverse, because these cancel. And x is about sine inverse 10 sine 23, all above 12. So x is about 19 degrees. And that quickly tells us theta. Let's go 180. Let's go 180 minus 23 minus 19. And theta is 138 degrees for theta, right? 138 degrees. And that goes in right there. 138 degrees. Then type all of that in. So let's see. 0.5 times 10 times 12 times the sine of 138. So the area is about 40.15 square units. 40.15 square units. We say square units, not units squared. It's more proper to say square units. Cool. Last one. Let's go. Number 11. Find the area of that guy. Oh, it's on the axes. Let's see what this has to offer. Let's take a look here. So we got 4, 7 for this guy. There. For this point. 4, 7. And this thingy is 103 degrees. Well, I'll tell you what, if I were to go like that, I know that this is 4 and that this is 7. And Pythagorean theorem can give you the hypotenuse, right? If we take a look at this triangle there, that little portion, that's a right triangle. You can go Pythagorean theorem, 16 plus 49. So look, this would be square root 65 for that guy there, right? Now, let me put a little 90 degrees there. And how about you guys find this angle x? And by the way, let me tell you what my strategy is. I want the area. I'm going to go like this. Watch. I'm going to use the same formula from the previous problem. I'm going to go area equals 1/2 side times the sine of theta. I'm going to choose 103 degrees. So I'm going to position myself right here. And the two sides will be this one and that one. And what's good is I already know one of them, square root 65. So I know for sure that if I use 103 as my angle, then my sides will be square root 65. And this guy here, call it y, which I don't know yet. I don't know why. I'll get there. First, let's find x way over here. So first, focus on x. How about we go SOHCAHTOA to find x? We could say tangent of x. Tangent is opposite over adjacent. If you're standing at x, your opposite and adjacent are 7 and 4. And you could go tangent inverse to find x. So x, if you go tangent inverse of both sides, all right, if you go tangent inverse of both sides, it's about 60.25 degrees. 60.25 degrees for x. And now that you know what x is, 60.25, you can go law of sines to find. Can we use law of sines? Let's see. How about we go? Yeah, we can. Look. Watch. Find this guy. Find the little angle. Let's go 103. 103 plus 60.25 and subtract it from 180. So this one here would be about 16.75 degrees. This one is 16.75 degrees. This is a nice problem, right? If you look at the whole triangle, That was 103. This one was 60 and change. That means this guy is going to be 16.75. Now we can use law of sines to find y, which is the other side, and plug it in right there. So here would be my setup for law of sines. Sine of 16.75 is to square root 65. If you look at the outer triangle, right? Sine 1675 over square root 65 equals the sine of 60.25, this angle here, over y. That's going to tell us y. So do the cross product there, and you'll see that y is about, let's see, divide this by sine 16.75. Square root 65 times the sine of 60.25, hit enter, and then divide by the sine of 16.75. So y is about 24.28 units. And that goes in here, 24.28. And theta is 103 that we used from earlier. So let's go 0.5 times square root 65 times 24.28 times the sine of 103, and we get about 95.34. So the area, final answer, would be about 95.34 square units. That problem was fun. And look, you could probably do this problem a bunch of different ways. Let me actually take, before we go, let me take a look at the answer key. That should have been it, right? Yes, he's about, that's what the answer key has. I think I might have rounded. I think I may have rounded a lot, which creates a discrepancy, because my answer, and compared to the answer key, there's a little bit of a discrepancy. I probably rounded a lot, or maybe they did, who knows? But either way, I'll accept anything close to something to that answer there. So your midterm is going to be friendlier and softer than this review worksheet. It really will. Taking a look at the front wasn't too bad, but things got a little interesting here in the back. So the midterm will be shorter and a little bit more student friendly compared to the review. Okay, so if you have any questions, let me know. If not, have a great weekend, and I'll see you guys soon. Bye.